So the question is, what is the angle that makes the cosine ratio be 1/2? According to things we've learned previously, if we have a 1 and a 2, then Pythagorean theorem would give us radical 3, making this a 30, 60, 90 triangle. The angle that gives you a cosine of 1/2 is 60 degrees. Another question, but take this hint. Using our unit circle and remembering that x goes with cosine, y goes with sine. If we're looking for what angle makes the sine ratio equal 0, the sine equals 0 here and here. So my answers are 0 and 180 degrees. So let's try a couple more. First of all, let's recall that if we're working with a radical 2, that would be on a 45, 45, 90 triangle where the side lengths are 1, 1, and radical 2. Either head back to your notes or do Pythagorean theorem. And while we're at it, we'll go ahead and we'll make the second triangle, the 30, 60, 90 triangle. And we'll say that that's theta for the time being. And we know that we would have a 1, a radical 3, and a 2. So then when I ask if the secant is radical 2, what would the angle be? So I'm going to be working with this triangle, but I have to remember that I'm flipping the cosine ratio to get the radical 2. So how would you get radical 2 over 1? That would be the same thing as if we were saying, what's the angle when the cosine ratio is 1 over radical 2? The answer is 45 degrees. But wait, this one's asking for radians. So remember, to convert to radians, you multiply by pi over 180. So I take my 45 degree angle and I multiply it by pi over 180, and then I simplify. 45 goes into 180 4 times. So my final answer here, where is the angle going to give a secant ratio of radical 2 over 1? At pi over 4. For my second question here, moving into the tangent, we're looking for the inverse tangent. So what angle gives a tangent ratio of radical 3 over 3? Tangent of radical 3 over 1, that would be 60 degrees. But we're going for radical 3 over 3, also known as this from the unrationalized denominator. But it makes it easier to see that we would have 1 over radical 3. So where did the 1 come from? Opposite would be opposite of the 30 degree angle. I say this because you need to remember that anything opposite of a radical 3 is the 60 degrees. So this must be 30 by default. However, once again, we must convert to radians. And my answer is pi over 6. So now for our last problem. To make this a little bit easier to see, let's de-rationalize, giving us the inverse cotangent of negative radical 3 over 3, also known as cotangent inverse of negative square root of 9 all over 3 radical 3, which becomes the inverse cotangent of negative 3 over 3 radical 3. Simplify, and we're looking at the inverse cotangent of negative 1 over radical 3. This means that when I go and flip cotangent to say tangent inverse, I'm also going to flip my ratio. And the ratio that would make the radical 3 over 1 happen for a tangent, radical 3 over 1, would make this theta have to be 60 degrees. But wait, we're looking at a negative, which means we've got to think about our quadrants, and all students taking calculus, everything is positive in quadrant 1, sine is positive in quadrant 2, so that could be one of our answers. Tangent is positive in quadrant 3, but we need it to be negative, so that's out. And cosine is positive in quadrant 4, which means that could be one of our answers. So what would it look like now? I'm looking for an inverse tangent, radical 3 over 1. It's got to be negative, so I'm in quadrant 2. Here my y is positive, but my x, coming from behind the x-axis, will be negative. This would be a 60-degree angle, reference, and a 120-degree corrected angle. Likewise, but wait, 120 degrees for a tangent does not fall between negative pi over 2 and positive pi over 2. So even though 120 is a correct mathematical answer, it doesn't fit the range, and therefore it is not an option. However, we do have another option, as discussed, in quadrant 4. With a tangent ratio of radical 3 over 1, but it must be negative, quadrant 4 will work because the y-coordinates are in fact negative. Since it's a radical 3, it's across from a 60-degree angle. That's my reference angle. So my answer could be 300 degrees, but that also fails to fall into, but 300 degrees also fails to fall into the prescribed range. Forcing us to think about the coterminal version, also known as negative 60 degrees, which does in fact fall between negative pi over 2 to positive pi over 2. So for this portion, negative 60 degrees times pi over 180, simplifying to get negative pi over 3 is your final answer. Here's a screen you should probably keep in mind when you're completing your online homework. It's only going to allow you to work with numbers within these domains for sine, cosine, and tangent inverses, and it's only going to allow you to describe the answers in these ranges. Now let's work on our second objective for the day, using compositions of identities and trig functions. I'm going to continue to work with the inverse notion, but I've got multiple things going on, hence the idea of composition. Back when you learned it in 7th grade, you have to work from the inside with parentheses moving outward. So start with just this. What is the sine of 2 pi over 3? Even more in depth, what is 2 pi over 3? Multiply that by pi on the denominator, 180 on the numerator, cancel, cancel. This is the same as 120 degrees. So what is the sine of 120 degrees? 90, 30 more for 120 degrees. The reference angle, going back to the x-axis at a right angle, this remainder right here is going to be 60 degrees. Mark in your side widths. Here we have a radical 3, the hypotenuse is 2, the initial side length across from a 30-degree angle is 1, but because we're going backwards from the origin, it's -1. So the sine of 120 is really going to be radical 3 over 2. Now take that out a bit further so we can finish the question. What is the angle whose sine ratio is radical 3 over 2? Well, clearly, radical 3 over 2 came from a 120-degree angle, but there might be more in other quadrants. For instance, quadrant 1, the sine would be radical 3 over 2. So that would be another potential answer. In quadrant 3, you would have a radical 3, but it's negative. The hypotenuse is 2. So that would not be an answer. Likewise, in quadrant 4, across from the 60 degree, you would have radical 3, but because it's going below the x-axis, it's negative. So this is also not an answer. My final answers for this question, as far as I know right now, are 120 and 60 degrees. But wait, you need to remember, the screen prior, we're looking at inverse functions, where the range is only expressed in a certain set of values. So from negative pi over 2 to positive pi over 2. So our 60-degree angle will work. From negative pi over 2 to positive pi over 2, 120 degrees does not fall there. It would not be listed as one of your potential answers. So let's try another one where we're looking at tangent of tangent inverse this time. Here I'm not going for exact values. My rusty trusty calculator tells me the very strange answer of negative 76.61 approximate degrees. However, ugly though it may be, now I'm just simply taking the tangent of that answer. This one's kind of cool because my answer turns out to be negative 4.2. Will it always work that way? No, but this one did. So for our last example, we're going to start with the parentheses version, working inside, heading outward, the sine of pi. The sine of pi at the point of negative 1, 0, sine is represented by y. So the inside portion of our answer is 0. And then you ask yourself, where is the cosine going to be 0? And your answers are either here or here. The first is at 90 degrees, also known as pi over 2. Your second answer is down on this portion of the unit circle. Because the cosine is 0, it's known as 270 degrees, or 3 pi over 2. However, once again, our inverse cosine is only defined between 0 and pi. 3 pi over 2 is not part of that definition of 0 to pi. So 3 pi over 2 is out. Final answer, pi over 2 or 90 degrees, depending on how the textbook would like it to be answered. And here's your homework.